Welcome to today's video lecture in which I am going to explain the Sol gel technique for the synthesis of nanoparticles. Actually, it is one of the video lecture in a series of lecture where I have explained the different methods of nanoparticle synthesis, including that of the hydrothermal method, the inert gas condensation method, and other methods also. So, the today's video lecture is all about the Sol gel synthesis. So, for the Sol gel synthesis, what do we have here is Sol gel is actually a method for producing solid materials from small molecules. So it is actually the formation of the solid material. That means the final product that you will get from the Sol gel method is going to be a solid powder. So in this procedure, the sol or the solution gradually evolves towards the formation of a gel-like diphasic system containing both a liquid phase and a solid phase. Okay, so in this process, in this procedure, what we have is the sol. First of all, we will have the formation of a sol, and this sol with age turns into a gel-like structure, and this gel-like structure will contain the solid as well as the liquid phase. The morphologies of this gel will range from discrete particles to continuous polymer networks. So in this gel structure, what do we have is we will have the solid particles, the solid phase as well as the liquid phase, and they will be in the form of discrete particles to continuous polymer networks. And then ultrafine and uniform ceramic powders can be formed by the precipitation, and finally through the precipitation what will be the product will be that of the ultrafine and uniform ceramic powders. These powders of single and multi-component composition can be produced on a nanoscale particle size for dental and biomedical application. Okay, so using this technique you can produce the single as well as the multiple component composition of the nanoparticles, and these nanoparticles you can use them for the dental as well as different biomedical applications. So now moving on towards how this general reaction takes place. So first of all, for the general method, first of all you have to uniformly mix the raw materials. Okay, you have to mix the raw materials in the liquid phase in the solvent, then you have to carry out the hydrolysis and polycondensation reaction. Okay, the next thing is you have to carry out the hydrolysis and polycondensation reaction, and this will result in the formation of a stable and transparent sol system. Okay, so the next thing you have to do, you have to just leave it for some time, and this sol will aggregate after aging to form this gel, this three-dimensional gel. Okay, so this gel network will be composed of the solid particle as well as the liquid particle. So there will be this phase will contain both the solid phase as well as the liquid phase. So after different processes like freeze drying, thermal drying and supercritical drying, the final product will be formed. Okay, so through the freeze drying, the cryogel will be formed. Through thermal drying, the zero gel will be formed, and through supercritical drying, the aerogel will be formed. So after the formation of this gel, what you can do, you can calcine it. Okay, so you can calcine it at higher temperature like 400 degrees C, 450 degrees C, 500, 700, depending on your substance you have to calcine it, and then the final product will be obtained. So finally, moving on towards the advantages. Why do we use this sol gel method? Well, the starting materials are in molecular level and the final product prepared are homogeneous. Okay, so this is one of the advantages, that the final product that is prepared through the sol gel method is homogeneous, and products are relatively higher in purity, and there is the controllable degree of porosity. So we have higher purity, and the porosity, that is the pores of the materials, can be controlled, the degree of porosity can be controlled, and it is easy to prepare various sizes and convenient to carry out. Actually it is convenient to carry out. You do not need higher temperature, you do not need high pressure, you can just perform it at the room temperature or different temperature depending upon your conditions. So enable synthesis at low temperature. So as compared to the hydrothermal method, in which you have to use the highly expensive autoclaves, in this method you do not have to use the expensive autoclaves or some other materials. You just have to you can just perform this at the low temperature. So it allows for the fine control of the product's chemical composition. So the chemical composition of the product can be controlled, especially suitable for preparing multi-component materials. So so it can be used for the formation of multi-component materials such as that of the mixed metal oxide or spinel oxide, that you can say, for example, copper ferrite. You can just form the copper ferrite through the sol gel method. So it enables small quantities of dopants to be introduced in the sole and end up uniformly dispersed in the final product. So you can perform the doping through this process. For the doping, what you have to do, you have to take the precursors. You have to take the precursors. After taking the precursors in the solvent, you just have to add the dopant. That should be like 5%, 7%, or 10% of the weight, depending on you. How much dopant do you want? Okay, so in the precursors, when you disperse the precursors in the solvent, what you have to do, you have to add the dopant in it and perform the sol gel synthesis just like that. Okay, so it enables small quantities of dopant to be introduced in the sole and it end up uniformly dispersed in the final product. So your dopant is uniformly dispersed in the final product. Finally, move on towards the disadvantages. As you can see that after a lot of advantages, we have these two disadvantages, that is relatively longer in reaction time. Actually, the reaction time for the sol gel method is much longer, and secondly, the organic solvents, they can be harmful for the human body. So these two are the disadvantages for the sol gel method. Okay, so that was all for today's video lecture. See you in the next video, and do not forget to like the video, subscribe the channel. If you have any question, you can ask me in the comments. Also subscribe to my Instagram account. Thank you and Allah Hafiz.